Hello, everyone, and welcome to my talk, Modern IDEs, the Swiss Army Knife for Developers. I'm Akash. I joined Cerner back in January of 2016, and I work in the RTHS platform team in our Bangalore office. Before we go ahead with everything that's planned, let me explain what this talk is about and what can you expect. So, first of all, let's look at what we will do. So as part of the live demo, I will create a Spring Boot application, which will write data to a MongoDB instance, which will be running locally on Docker. And we'll do all this without minimizing the ID. So that's kind of the USP of this talk. And just to explain a little bit more, uh, this talk is not intended just for Java developers. While I will be writing code in Java, the idea is to have a fun hands-on session where we will talk about often overlooked features of modern IDs. So with that, let's start with the first step. All right, so the first step would be to create the project. So first, let me explain the screenshot which you're seeing in front of you. So for people who are not too familiar with Spring development, this website is called start.spring.io. You can go there and you can actually create uh, a starter, a Spring starter from within the browser itself. You can add dependencies, you can choose which Spring Boot version do you want to use, which is your target language, and which is your target language version, and so on. So once you do all that and click generate, it actually gives you a zip file which you can use as your initial repository. So now we could have done that, but the USP of this talk is to not minimize the ID at all. So we will actually use the Spring initializer from within our IDE to create a new Spring Boot project. All right, so I'm on the new project screen and Spring Initializer is selected. So let's name our project. So I'm going to name my project Pokemon app. As you would have seen that uh, Pokemon is a general theme throughout the talk, and you'll see more of it later. So let me just edit the group, and we look okay. So we'll be using Java 17 as our target JDK. Should be okay. And that's it. So I'll click next, and what it'll do is that it'll actually ask me for dependencies. So similar to the website which I explained earlier, you can add anything which you would require here. So for my app, we need Lombok, which is a annotation library which helps in reducing boilerplate code. We'll need Spring Web because we're writing a web app. And we'll obviously need Mongo because we're trying to interact with Mongo. So we added three dependencies and then I click create. So it will now create the project and open it in front of you. So let's wait for that. All right. So what you're seeing right now in front of you is uh, the the application that we created with the three dependencies that we announced is being created right now. And the first time I need to set something up, do that, and it will download all the dependencies that it needs. Uh, and once all that is done, we should be able to interact with our application. All right. So let me walk you around the the app before we start actually developing. So, um, so if we look at the pom.xml, because we selected that we want to create a Maven app, you can see that the dependencies that we wanted, they've been added. So Lombok is one, and then it added the two dependencies, one for Mongo and one for web. So all that has been done. So that means like I didn't have to waste a lot of time waiting to add my dependencies and all that stuff. As soon as my project is synced, I should be ideally ready to code. All right. So it also created the entry point, uh, which is this. So once this project builds, I should be able to run this uh, from here, and the Spring Boot application will start. All right. So now let's look at the next step. All right. So the next step is obviously we'll start writing code. The first step will be to create our data models. So we are going to use our application to store Pokemons and kind of just maintain a few Pokemons in the MongoDB. First of all, we'll need the data model, and then we'll need the REST controllers and the data repository. So let me explain a little bit before we go ahead. Uh, Data model is visible in front of you. We'll have a Pokemon which is defined by the index, uh, which will be the unique key. Like one is Bulbasaur, two is Ivysaur, and so on. You guys know that. Moves will be a list of string, the moves that the Pokemon has, the name of the Pokemon, and then the type of the Pokemon. So traditionally, in a Pokemon can have at max two types. That is why you see a type 1 and type 2, which is a primary type and a secondary type. And then we have an enum type, which is all the known types so far. The REST controllers will actually have our APIs, which will interact with the data repository. So now let me take a little bit time to explain what data repositories are in Spring, because we'll be leveraging a lot of it uh, as we go ahead. All right, so Spring provides something called data repositories, which is another way for uh, developers to reduce boilerplate code. What it means is that you can just use a pre-written, already existing repository, like a CRUD repository, or in our example, we'll actually use the simple MongoDB repository. And what this means is that you don't need to write the actual code for simple operations, like creating your data and updating data, deleting data, and so on. And this significantly reduces the boilerplate code, which we just repeat over and over again in projects. And another feature which we leverage is something called query methods. So Mongo repository gives this thing called that you can just write a field name. Uh, you can write a method by the field name, and it will actually uh, infer the code that it needs for you to uh, you know, work with that field. We'll see an example later, but I just wanted to give a heads up there. All right, so let's now switch to our Spring Boot application and start writing the code. All right, so as I said, the first thing that we need to do is create the model. Let's create a model package, and let's create our Pokemon uh, Pokemon data model. All right, so as shown in the earlier diagram, we need an index, which is our primary key. We need a name. We need a list of string, which will be moves. And then we need to declare our types. Before we do that, we'll actually need the enum. So let's go ahead and create a enum. So let's call it type. And so I'm going to use something called uh, live templates in the ID. So that actually lets you store some code which you might reuse here and there and store them as templates. So what I did right now was I used the template called Pokemon underscore types, and then I just pre-populated this list rather than wasting time here. All right, so now that we have this, the general style of enums is to have them in uppercase. So we'll do that using Control Shift U. I was able to toggle case of all the members in the enum in one go. So now that we have our type, we can go back to our Pokemon class and mention the two types which we wanted to do. So now I have this. So generally after this, you will write your getters, setters, and so on. But remember, we added something called Lombok when we were creating the project. So Lombok is a annotation library in Java, uh, which just lets you reduce a lot of boilerplate code. So all I need to do is include the data annotation from Lombok, and if we actually go and check, what it says in a Java docs, it will say that it generates the getters, setters, a toString, equals and hash code method, and so on. So it creates all these things for you by default. Uh, so we'll add a few more things. We'll add a builder just in case we want to use the builder pattern, and we'll add a no args constructor as well. So um, and this will require me to add this. All right. So with this, we have our data model ready. Now the next thing to do would be to actually create the data repository, which I was talking about. All right, so the data repository needs to be an interface, and let's call it Pokemon data repository. Okay. So now I talked greatly about this earlier. All we need to do is extend something called Mongo repository. Um, and it will need to know which is our data model, which we want to put in the database. So in our case, it is Pokemon, and it will need to know the type of the primary key, which in our case is integer. That also reminds me that we'll go back and add the Spring data annotations ID here, just so that it knows that it's a it's a primary. All right. So now we created the data repository as well. The next thing to do will be to actually create the controller. So let's do this, and let's start writing our controller. So I explained earlier, but let me just quickly revise. We want to create an application to write Pokemons into the database. So we'll probably need a post. Uh, a post endpoint which will let us write these Pokemons. Then probably we need uh, a get which will let us view these Pokemon, and then probably we'll throw in a delete so that in case we do any mistake, we can clean this up. So the first thing that I want to do is annotate this class with REST controller, and then we'll create the top level mapping. Let's say our endpoint is slash Pokemon. Next thing we need is our data repository. So let's create that. We marked it final, so we need to add it as a constructor parameter. So I quickly use the suggestion to do that, but I didn't have to write a lot of code. And then let's write our let's start with our post mapping. Okay, so uh, we need to write um, uh, a method which will help us in saving our Pokemon, right? As simple as that. Uh, so now let's call it this. Um, our request body will be a Pokemon, and now so far you only saw me uh, declare a Pokemon data repository. We don't know what it does, how it works, and all that stuff. So now let's just use this repository and do and see what methods it has first of all. So it has something like it has save methods, it has find methods, it has delete methods. So all the CRUD methods which you can think of are already there. We just need to implement them at the right place. So this is reducing a lot of our boilerplate code. So now if you're curious, uh, this is the CRUD repository which Spring provides. And if you want to look at the implementation, what it does, I can click there. And right now I'm in this class called simple Mongo repository. And the save, if you look at the save class, it is just calling a helper called Mongo operations, and it's actually inserting the entity. So pretty cool. Anyway, so let's go back to our controller. So we already have our post mapping. Next, we would probably want to have a get mapping. Uh, so let's say public list of Pokemon and Pokemon method is. So for now, let's say that our method uh, just returns everything which is there. So we try to find a suitable find method. So we can see find all here. And once we do that, our get mapping is ready. Another API which might make sense here is uh, a get mapping for a specific index. So in case you only want to see one specific Pokemon, it makes sense. So let's uh, do this get Pokemon by index, and then we will say that this is a path variable, which is an integer, which is an index, and then what we can do is we can do return repository dot find by ID, and then we can pass our index. So it actually right now is complaining about that there might be a case where this Pokemon doesn't exist at all, right? Which makes sense. There might be a use case where uh, the index that we are trying to access doesn't exist. So let's create some simple exception handling into our application. So let's create a exception called Pokemon not found exception. All right. And I will actually go and use the live templates to fill it up. So let's just quickly look at what it's trying to do. So this is a Pokemon not found exception. It extends a runtime exception and it returns a HTTP status code of not found, which is 404. And there is a helper log message that Pokemon number, whatever we were trying to look, was not found. So now, if we come back to the controller, what we can do here is we can do something like this. So we can write or else throw. So in case if it doesn't find the the Pokemon that we are looking for, it, we will make it throw in Pokemon not found exception, which we just wrote. So that gets us to three APIs. Let's quickly sorry, let's quickly throw in a delete API, and then we'll start doing some other things. All right, so delete Pokemon. And let's say that we want to allow deleting by a specific ID only at this point. So this guy, and then the delete methods are already there. So we'll probably need to do delete by ID, and we'll pass the index here, and then this, that's it, done. So we have our four APIs, uh, which are like simple API for us to get started. But right now, there's a major thing missing in our application. So we say that we are trying to write to a Mongo database, but that doesn't exist. So in the next step, if I go back to my anchors, uh, the next step is to actually set up MongoDB. All right, so the next step would be to set up Mongo on our Docker and then establish connection to this instance. So Mongo already has an official image from Docker. We just need to pull it uh, into our ID and then create a Docker container from that image so that we can start interacting with it. So now let's see how we do that. So from within the IDE itself, what I can do is I can go to the services tab, and then I can see that there's a Docker service here. I can do right click and connect, and then it'll connect to my Docker instance. So I already have Docker for Windows installed, which is running in the background. So let's go ahead and do connect. So right now I don't have any containers, any images. So the next thing to do would be pull an image. And if we remember from the previous screenshot, the official image is called Mongo. So let's select that, and then we'll click pull. So as soon as I do that, by default, Docker pulls the latest tag. So it'll try to download it and get the image set up locally. Once this image is downloaded, what we'll do is we'll actually create a container out of it. So that our Spring application can interact with that Mongo instance. So almost done here. It complete downloading. It is extracting. Um, all right. So it downloaded the latest Mongo image. Now the next step is to right click on it and create a container. So let's just call it uh, Mongo for Pokemon, right? And then our container name could be something like Mongo Pokemon. Doesn't really matter. One thing that we need to do here is bind our ports so that our Spring application can actually talk to the instance and get things running. So the way to do that is modify options, click on bind ports, then click on this option here and create a host port. I'm just making sure that I write the right port number, which is the default port for Mongo is 27017. Just like for MySQL, it is 3306. So I'll write that, and then I will click run. So as soon as I click run, what it does is it creates a container from the image that I have, and it tries to start it. So it has already deployed it successfully. Um, So we can see that there are some logs. So Mongo logs everything as a JSON. That is why you see a lot of JSON here. And it seems like it did a bit of logging. So we can assume that the container started just fine. All right. So the next thing to do would be to first move my camera a little bit so that we can look at the database explorer. So the Database Explorer window is basically a way for us to uh, connect to database instances from within the ID. So we don't need to worry about using other tool or things like that. So I selected a Mongo source and let's just name it Mongo. Doesn't matter. And then everything is filled up. So it knows that the default port is 27017. Uh, it is set up locally. We didn't set any authentication, so it should just work. So let's just click test connection and see what happens. So if anyone has worked with any database port, the 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 problem is that you always need a driver and somehow or the other you always forget about it. So I can actually come here and I can get the driver file uh, from from this window itself. So I can just say that give me the latest driver file, and then I can go back and then switch to this driver and then try to test connection again. If everything is set up properly, then we should actually see a connection successful popping up here. So let's hope for that. Yep. So we were able to succeed to connect to our Mongo instance, which means that we were able to set up our database properly. All right. So now, now that we have now that we have set up Mongo, let's look at the next step. the next step is to actually insert some data. So we've already created some endpoints which are there. Now we need to hit those endpoints and insert data. Ideally, at this step, you would use something like Postman or Advanced REST Client or your browser to basically hit these endpoints. But a lot of these modern IDs, what they have is they have something called they are basically a HTTP client embedded in themselves. So you can actually interact with the APIs from within the ID itself. So first of all, let's go to our Pokemon controller, and the first thing I want to do right now is to just verify that all the endpoints that we created, they're showing up properly. So there is an endpoints tab here. I clicked on that, and I can see that I have a slash Pokemon get, I have a slash Pokemon post, slash Pokemon delete, and I have a slash Pokemon slash path variable index get. So these are all the four API endpoints that we created. Okay, so the next thing to do will be actually uh, try to hit this method to save some data because right now our database is empty. So what I can do is this post mapping annotation, you can see a web browser sort of thing here. All right, so it has a few options. It lets me view the endpoints of the module which we just saw. And if you see the middle option here, it says something like generate request in HTTP client. Let's go ahead and click that. And this takes me to this window, which actually lets us hit these APIs. So localhost 8080 is fine. We don't need to change that. And because we came from the post mapping, these things are already filled out. So now let's go ahead and first of all add our content type header. And then what do we need next? The next thing we need is the actual body. So I already have 5 Pokemons here. Let's just select the first one. So Bulbasaur, number one, and it's grass and poison. And let's just go ahead and hit this endpoint. So as soon as we hit this endpoint, what error do we expect? Uh, it fails to connect because we never started our Spring application. So let's go here, click this, which will actually turn our Spring Boot application on for the first time. And Lombok requires some processing. We'll get that. And then uh, we'll wait for it to run. Uh, once it once it is up and running, we can hit this endpoint again. All right, so it looks like it is trying to start up. All right, so started Pokemon application in 5.581 seconds, which is good. So now let's come here and hit this post again. All right, so as soon as I clicked the run arrow here, it was able to make the connection and it got 200 as a response, which is good because we like that. All right, so now the next thing to do will be to quickly check uh, this data before we go ahead. So let's come back to our database explorer and let's click refresh. We should expect to see something here. And we indeed do see a collection called Pokemon, which is correct because that's what we are trying to store. And let's now see if there are any documents within it. Uh, so in Mongo, uh, uh, a single entity in a database is called a document, and the table itself is called collection. So that is the nomenclature there. Anyway, so now let's see what this looks like. So whatever we try to store, it seemed to have worked. So now let's go ahead and probably store a few more before we go ahead. So I can copy this up and I'll throw in a Charmander. I'll throw in Waddle, all the starters from the first generation. And people will complain if you don't do Pikachu, and I will complain if I don't do my favorite Pokemon, which is Lapras. So, all right, so now let's hit this. This I can hit them all at once as well, but I just want to ensure that I don't end up creating duplicate requests. So you can see that there were 5 requests which went through. That means the next time we click on this, we should see 5, which is correct. Um, all right, so now uh, let's try to use some of the other APIs which we have created. Um, First of all, let's try to create this, test this get API. So like previously, it just filled up everything. As soon as I hit that, I'm able to see all the different Pokemon which we have stored. We have another get endpoint, which is get by the index. So let's go ahead and do that. So it fills up that, and it obviously wants you to fill in the index before hitting it. So let's put in Lapras, and we do get it. Just in case we hit something which we have not stored, let's say number 2, which should be Ivysaur, but we have not stored it. This guy throws a 404 because of the way that we set up the not found exception. And yeah, that's kind of the all the different APIs that we wrote. So now let's go in and probably write some make some changes to these to these classes and just see if we can enhance some of this a little bit. A logical addition could be that you want to query all the Pokemon that we have by a specific type. So you might want to see all the grass Pokemon which you have uh, in your database so far. So to do that, the first thing that we need to worry about is there a way for our database to give us that specific information? So right now, if you're following these repository-based methods, they are kind of surrounded around the primary key, which in our case is the index. So we actually need to go and add some methods here. So now this goes back to the query method style which I was talking about, and you can read more about it on the Mongo repository tutorial on Spring. But essentially, you can uh, write methods in this format, uh, and Spring and Mongo will just fill it up for you. So we actually have 2 types. So we will create 2 methods which will help us find by these specific types. And then in our controller, we need a place to add this. So the logical place to add this will be in the default get mapping, where we can just probably introduce a, a optional parameter which can let you query by type. So I already have that code here. Uh, in a live template. So let's look at that. So at the rate request param, value is equal to type, required is equal to false, and string type. So that means you can pass in a type and then expect something to return. If type is not equal to null, we will use that to query. Otherwise, we will just use our default return of find all. All right, nice and easy. Uh, let's just format this code quickly and get our imports in. So it shouldn't matter whether a Pokemon is of a certain type in type 1 or type 2, we'll let people query. So now that we have this set up, let's go ahead and test it out. So first of all, we need to restart our application because it's still running on the old code base. So let's just quickly rerun and wait for it to start. Go back to the controller and yeah, let's generate this request. All right, so this is our default get. If I run this, I will get everything. So now let's try to add the type. So we have two water type Pokemon. Let's see if that works. So it did work because it returned two entities. So yeah, that's kind of uh, some getting into some Spring data repository stuff. Anyway, so let's go back to our anchors, see if we did everything. So we did insert the data using the HTTP client. We didn't need to navigate away to another tool. We also used the database tool window to verify the data. We were able to connect to our Mongo instance and actually look at the collections uh, of all the data that we inserted. Uh, the final step I have here is to share this code that we wrote with everyone else. So we want to basically get this code onto GitHub. So let's see what options we have here. So I click on the Git menu item here, and there is a GitHub option, and it gives me directly an option to share the project on GitHub. So I already have my access token and everything set up with my personal GitHub account. So it will try to connect that to that. And let's say I'm okay with whatever it has right now, and I'll click share. So as soon as I click share, it will ask me what all I want to commit. So I can quickly look at all the files which I would want there. All these look good. Um, Pokemon Station, let's say V1. Add. As soon as I do add, it actually pushes onto GitHub. So I didn't have to navigate away from the ID to get my code to GitHub as well, which is pretty cool. Anyway, so that's that's kind of all that I had. Like I said earlier, this was a fun hands-on session uh, to kind of poke you in the right direction of exploring these features which your ID might have. And like as you saw, we created an application from start to scratch. We also kind of did a PPT from within the ID itself. We didn't minimize the ID at all in the whole duration of the talk. And you were able to create a Spring Boot application, use Docker to get an image, create a Docker container, connect to that Docker container from Spring, and finally share the code, test the code using our HTTP client, and then finally share the code on GitHub. So all this from within the ID. So imagine how many, uh, you know, uh, changing focus from ID to other tools we were able to save here. So hopefully this inspires you to explore your ID a little bit more and use these helpful features, uh, which might help you in your daily work. So yeah, with that, this is Akash signing off. And please don't forget to leave any feedback that you may have